when any decimal number system number is given and it is to be converted into other number system, then the procedure is that whatever is the decimal number is given, that number to that number, you go on divide by the base of other number system, base of other number system, and every time go on checking only the remainders. These remainders we have to take in the reverse order. This is for the integer part of the given number. For fractional part, go on multiply by the base to the fractional part. Every time get only its integer part and remaining fractional part again goes for the multiplication. This is until the number of digits, required number of digits after decimal point. So let's see how the process works. So first let us convert decimal to octal. Octal means base is 8. So any number suppose given 50, suppose number is 50 decimal number, we want to convert into octal. So take the number 50, divide by the base, that is 8. Go on writing quotients here and go on writing remainders here every time. So 50 divided by 8, 8 6 are 48. So 6 will be the quotient and 48, so 2 is the remainder. Now 6 divided by 8, so 0 will be the quotient and 6 will be the remainder. Now these remainders we have to take in the reverse order, starting from this ending towards this. So 62. So the number becomes 62 octal. So 50 decimal means 62 octal. 50 decimal is 62 octal. Let's have one more example. Suppose the decimal number is in decimal number system, take some number, suppose 275. 275 is a big number. So 275, take the number, that is a decimal number. We have to convert into octal. So divide by 8. So 8 3s are 24, 3 5 35, 8 4s are 32, 33 34 35. So 3 will be the remainder. So remainder on this side, quotient on this side. Now 34 divided by 8. Go on dividing until the quotient is 0. Go on dividing until the quotient is 0. Every time write quotient in this column, remainder in this column. So 34 divided by 8. So 8 4s are 32. So 4 here, 32. So 33, 34. 2 will be the remainder. Now 4 divided by 8. 0 will be the quotient and 4 will be the remainder. Take the remainders in opposite direction. So 4, 2, 3. So that is 4, 2, 3 octal. So 275 decimal is 423 octal. So this is for the integer part of the conversion. So for the integer part, we have to divide by the base. Now let's consider the fractional part. Consider any fractional part. Suppose fractional part is say 0.45 decimal and we want to convert this into octal. Convert 0.45 decimal into octal. So octal means base 8. So multiply to this fractional part by 8. So 0.45 multiplied by 8. So now we need a calculator to calculate this. So let's use the calculator. So 0.45 cross 8 is equal to 3.6. So 3.6. Out of this, take only integer part as 3 here and take the fractional part for the next multiplication. So 0.6 into 8, 4.8. So take this again 4 here, 0.8 for the next multiplication. 6. Take this 6. So go on doing this procedure until the fractional part is 0 or until the required number of digits after the decimal point. These digits are after the decimal point and they are to be taken in this sequence after the decimal point. So the number will be 0.3, then 4 and then 6. 346. So 0.45 decimal is equal to 0.346 octal. In this way the fractional number works. So this way the fractional number. Now let's consider one combined number. Integer plus fraction. Take some number, suppose decimal number, say 25.75. This is a decimal number. Convert into octal. So let us separate this integer part and the fraction. So 25, for this 25, divide by 8. 8 3s are 24. This is a remainder. This is a quotient. 3 divided by 8, 0. This is 3. So this number becomes 31. So 31 is the integer part of the conversion. Now fractional part. 0.75 into 8. 0.75 into 8. So let's use the calculator to calculate this. So 0.75 into 8. Oh, very good. It is coming 6. So here, for a change, it is just 6 and there is no fractional part. So here it ends. So this number is just 31.6 in octal form. So 25.75 decimal is equal to 31.6 in the octal. This 0.75 has made it simplified. Actually, instead of 0.75, suppose the number is 0.7 only, then it will not be so simple as 0.6. In that case, suppose 0.7 is there. 0.7 into 8, you will get 5.6. Then 0.6 into 8, you will get 4.8. So the number will be 0.54 in this case. So when 0.7 is there, it is smaller. So 0.54 is also small. 0.75 is bigger, so it has become 0.6. That is also. So this is the way of conversion from decimal to octal. Now exactly similar procedure will be used for decimal to hexadecimal also. In hexadecimal the base is 16. So we have to divide or multiply whatever 16. Now let us consider any number, decimal number. Let us take 75 decimal number and convert into hex. 75 is integer part, so use only integer part. 75 divided by 16. 16 1s are 16, 16 2s are 32, then 48, 16 4s are 64, 16 5s are 80, so 16 4s are 64. So after 64, count up to 75 to get the remainder. So 64 74 is 10, 75 is 11. So 11 will be the remainder and 4 is the quotient. Now 4 divided by 16. So quotient is 0 and remainder is 4. Now in hex, 11 means B. 11 means B. We have to remember this. A, B, C, D, E, F are 10, 11, 12, 13, 14 and 15. So this remainder we have to take in the reverse order. So first is 4 and then is B. So 4B will be the number. So 75 decimal is equal to 4B in hex. So in this way the conversion takes place. We'll have one more example. Let's take suppose 225, a bigger number. 225 decimal convert into hex. So 225. So 225 divide by 16. 16 ones are 16. Then 16 to 22 is 6, 65. So 16 4s are 64. So remainder is 1. So remainder is 1. This is a quotient. Now 14 divided by 16. So naturally quotient is 0. Remainder is 14. 14 in 14 in hex is E. Take the remainders in the opposite direction. So the first will be E and then will be 1. So 225 decimal is E1 in hex format. E1 in hex format. So this is for the integer part. Now let's see for the fractional part. For the fractional part, let's take any fraction. Fractional number. Suppose 0.4 decimal and convert into hex. So for the fractional part, we have to multiply by 16. So 0.4 into 16. In case of fractional part, we have to decide how many digits will be there after the decimal point. So 0.4 into 16. 0.4 into 16. It comes out to be 6.4. Out of that, 6 is the integer part. Take it as it is. 0.4 for the next. Again 0.4 coming. 0.4 into 16. It will always come 6.4. So 6 will be there. So this number will be after decimal point. Take in the same direction. So first this 6. Then this 6, 6. Here 6 is coming. So direction is not actually important. In the next example, we'll see that direction also. One more example we will have the combined. So in this way the fractional part is converted. Let's have one combined number, suppose, for example. So suppose the number in decimal is 165 point suppose 8. 162. Okay? 8. This is a decimal. Now 165 is the integer part, 0.8 is the fractional part. So separately we have to do it. So 165 divided by 16. Convert this decimal number into hexadecimal. So 16 ones are 16, then 0, and the remainder will be 5. This is a quotient. 10 divided by 16, this is 0, and 10. 10 in hex is A. So the number in this integer part will be A5. A5 is the integer part. Now let's find out fractional part. 0.8 into 16. Multiply by the base value. Base value is 16. So multiply by 16. So let's multiply this 0.8 into 16. So it is coming out to be 12.8. By chance everything is same. Again 0.8 is coming. Let's let it be. But we'll have one more example where there will not be same coming. 12.8. So 12 will be coming out. Again 0.8 into 16. 12.8. So 12 will be coming out. That is 12 in hex is C. So the hex converted number will be A5.cc will be the hex number corresponding to this. Now I will show you one more fractional part where their continuous is not coming. So let's have suppose 0.35 decimal and let's convert into hex. 0.35 decimal. Let's convert into hex for say 2 digits after the decimal point. So 2 or 3 digits. 0.35 into 16. What we have to find out? 0.35 into 16. So 0.35 into 16 is coming out to be 5.6. 5.6. So out of that 5 will be taken out and 0.6 will be taken for the next conversion. So 0.6 into 16. So again 0.6 into 16. It is coming out to be 9.6. 9.6. So 9 will be coming out 0.6. So 5 and 9 are the 2 digits. You have to take in the same direction. After decimal point, put the numbers first this 5 and then this 9. So 0.59. So 0.35 in decimal is equal to 0.59 in hex. In this way the conversion is done. So exactly similar method will be used for the conversion from decimal to binary also. In case of binary, the base is 2. So we have to divide everything by 2. So let's take any number. Suppose the simplest number is 50. 50 decimal. Let's take 50 decimal and convert into binary. So 50 divide by 2. Go on dividing by 2. 50. So quotient is 25. Remainder is 0. 25 divided by 2. Quotient is 12. Remainder is 0. 12 divided by 2. 6. 0. 6 divided by 2. 3. 0. 3 divided by 2. 1. Remainder is 1. 1 divided by 2. Quotient is 0. Remainder is 1. Take these all remainders in the opposite direction. So the number becomes from this is 1, then this 1, then this 0, then this 0, then this 1, and then this 0. So the number becomes 110010. So this is 50 decimal converted to binary. This is the binary equivalent of 50 decimal. Let's have one more example. Let's take slightly bigger. Suppose any decimal number. Suppose 121. 121 is a decimal number. Convert into binary. So 121 divide by 2. 260. Remainder is 1. This is remainder here. This is quotient here. Now 60 divided by 2 is 30. 0. 15. 0. Then 7. 1. 7 divided by 2 will be 3 2s are 6. 1. 3 divided by 2. 1. 1. 0. Take all the remainders in the opposite direction. So the answer will be 1 1 1 1 0 0 1. Now we know how to convert binary to decimal. Let's check this and confirm that the number comes out to be 121. This is 1. So this is 2 raised to 0. So this has to be 1. 2 raised to 1. 2 raised to 2. This is 2 raised to 3. So 8. 2 raised to 4. So that is 16. 2 raised to 5. That is 32. 2 raised to 6. That is 64. When you add all of these, you will get the number 121. You have to get it. Otherwise, something is wrong in the calculation. You can check it. So in this way, the conversion is done. Now let's see for the fractional part. For the fraction part, you have to multiply by 2. So take some number. Let's take some number as suppose 85.4 in decimal and convert into binary. Suppose 85.4 into binary. In the exam, mostly the fractional part is not asked, only the integer parts are asked, but we should know how to convert. So separate the integer part and fraction part. So 85 divided by 2. 4. 2. Remainder is 1. This is a quotient. 42 means 84. Yes, 42. So 21. 0. 10. 1. 5. 0. 5 divided by 2 is 2 2s are 4. So 2. 2 2s are 4. So this is 1. 2 divided by 2 is 1. So 0. 1 divided by 2 is 0. 1. Take all the numbers in this direction. So the number is 1010101. This is the integer part, which is equivalent to 85. Now we have to do for 0.4. So 0.4 is the fractional part. Multiply by 2. 0.8. 0.8 integer part is 0. So take it 0. Take this 0.8 for the next multiplication. 0.8 into 2. So it comes out to be 1.6. Separate this one as integer. Take this 0.6 for the next multiplication. 0.6 into 2. It is 1.2. So this one will be separated. 0.2 for the next multiplication. 0.2 into 2. That is 0.4. So 0 is here. So let us decide that there will be 4 bits after the decimal point. Then the sequence will be this. So this will be after decimal point, first this 0, then this 1, then this 1, and then this 0. So this becomes the fractional part, which is equivalent to 0.4 of this. When the two numbers are combined, we get 1 0, 1 0, 1 0, 1, 0.011. You can drop this trailing 0. This is the number binary, which is actually equivalent to 85.4 decimal. So 85.4 decimal is equivalent to this binary. So this is the way we convert any decimal number system into the binary. If it is asked that any number we want to convert into binary or octal or hex, then what is the shortcut we should understand? Let's take some random number in decimal. Suppose the decimal number is say 211. Now let's convert this into octal also, hex also, and binary also, and check it. So for binary number 211, let's divide by 2. So 2105, 1 remainder. 105, then 52, 1 remainder. Then 26, 0 remainder. 13, 0 remainder. 6, 6 to the 12, so 1 remainder. 3, 0 remainder. 1 is 1 remainder, and 1 divided by 2, 0, 1 remainder. So these are all the remainders which are taken in this direction. So this number comes out to be 11010011. This is the answer number which is in binary form. Now let's convert the same number into octal. So 211 divided by 8. So 8 ones are 8, 2s are 16, 5 and 1, 8, 6 are 48, 49, 50, 51, 3 will be the remainder, 26. 8 ones are 8, 2s are 16, 8, 3s are 24, 2 will be the remainder, and 3, this is 0 and 3. So the number becomes 323 in octal form. This is a binary form, 323 in octal form. Now let's do the same thing for hex also. So 211 divided by 16. Sorry. 211 divided by 16. So what we get is 16. 1s are 16. 5, 1. 16, 3s are 48. Then remainder will be 3. 13 divided by 16 is 0. So this is 13. 13 in 13 in hex means D. So this number comes out to be in this direction D3. This is D3 in hexadecimal. Now we have got 3 answers, one in decimal, one in hex, one in octal, and one in binary. They all should be same. Now we know the interconversion between them. Let's confirm that. What is D? D is C is 1100, D is 1101, and 3 is 0011. So let's check that this is same as this. And in case of octal also, 3 is 011, 2 is 010, again 3 is 011. So you can drop the leading zeros. So you can see that this and this are the same. So if it is asked to convert into binary or hex or octal, you can see that conversion into hex is the shortest. Once you convert, because it involves only 2 3 steps, here there are many steps. If you observe in binary, there are many steps. If you observe in hex, there are less steps. But once you convert, you can immediately convert into binary if you know the exact expansions of 0 to f into their 4 4-bit numbers.